Hey guys, welcome back yet again to another mind test tutorial. Today we're going to be talking, continuing conversation about Lua controllers. Let's get started. So here we are where we left off last class. To get here, you're going to have to open up mind test and then click on the 2021 class. Let's just do that real quick. Okay, so we're going to click on just one time though. Keep doing that. Alright, so we're in our mind test game. No adding mods this time. Simply click on the world and play game. Okay, so here we are at our Lua controller. We can right click on our Lua controller to pull up the text editor and see what we wrote last time. Just a brief overview. Here we have a comment. The program skips that. That is for me and you to read, not for the computer. And we denote our comments with a double hyphen. And so then it just skips it. Next line is we've set port A equal to true. Like I said last time, you can also change the other ones and change them using true or false, or 1 or 0, and there you go. It's turned port B on. Now, if I say, okay, I really don't want port B on, well, what do? I just set it to off. And if I get this out of the way, it doesn't work because 0 doesn't work, so we have to use false. Alright, so now if I press execute, and press escape, turns off. Wow, why? Much better. Okay, my finger fat fingered it there. So, all right. So we have correctly outputted information through A and B. Now, when I say information, I'm not talking about like words and numbers. No, I'm talking about on or off, and that is a very, very common method of communication for devices, computer devices. In particular, the technical term would be digital devices. It's the on and off way of communicating. This is also known as binary. This two states, on or off. So that is what we're working with, a digital device which uses on or off to communicate. Right, so that's fine and dandy, but this is extremely boring and useless if all we can do is turn it on or off. I know a better way of doing that. Let me show you. If we go over here to our inventory and type mesicon, and we find a humble switch. Grab the switch and we plop it down right here. And we say, okay, switch, you go here, and we grab a little messy wire, break this wire, and look, I can do the same thing. Why in the world would I use a mesicon wire in order to turn that light on, or a Lua controller to turn that light on? Well, let me show you why. This will still be simple, and so you won't quite appreciate the value of it just yet, but we're getting there. I need to introduce to you inputs. Now, here we have a switch. I have wired it into my Lua controller. We want to make note that I've wired it into port D. It's getting late, so let's do a /time 6000 and make it morning again. All right, so what am I going to do here? I've got my switch in, and if I hit this, what does it do? Nothing. It doesn't do anything. Well, it's because we haven't told it to do anything with that port, with port D. Now, remember how I was telling you there's inputs and outputs? Well, port refers to the output state of a pin and does not at all refer to what's coming in, okay? So, how do we test to see the state of D? Well, we use something called pin. And this is the input state of a pin. So, pin D, for instance, would give us a true or a false value depending on what the switch is set to. So then if this right here, pin D, if that has a value of true or false, depending on what we're putting in to D, right? That switch, we can turn it on or off. That mesicon gets bright or dark, depending on its state. If it has a value of true or false, couldn't we substitute or replace one of these values with pin D? Couldn't we? Well, let's try that. Let's go over here to, let's actually just type it out. So I'm going to erase pin D, go up to port A because that's where our light is. Man, I'm going to write pin.D and then enter to get that line back where it's supposed to be and type the P. So hopefully you don't have to do all that. But I'm just going to add after port.A equals, I'm going to replace true with pin.D. Now if I press execute, we notice that the state of the light does change, and it actually mimics with a delay, as you can see here. As we turn this on, there's a slight delay, but it does mimic it, and it turns the light on or off. Now let's just say, for instance, just kind of fun, that we want D, so we want pin port B to be the opposite. Well, let's see if that's possible. I think that's possible by writing not equal to pin.D. I haven't tried this yet, but I believe it's possible. If we press execute and exit, it does not work. So, and there was actually some debug information there. Yeah, it was expecting an equal sign. So, sorry, that's not possible yet. But we are going to get into the relational operators here in just a second. Well, next class. But that is inputs. So simply so port is referencing your outputs. Pins are referencing your inputs. So what do we? How can we remember this? Well, one way that I like to remember it by is the PO. The O you can think of as being like output, and the I here is like input. So PIN is in, and then port is like out, right? So you know that if you write port.A, that's going to change the state of an output. It's going to set a port to high or to low. And you know, if you write pin, you're going to be testing, or you're going to be getting the value of a pin. Now, something you might be wondering about, you might not be, I don't know, but when can we expect the Lua controller to run the code inside that we've given it? Well, this happens every single time there is an event. Events are typically inputs. So the code inside is sitting there doing nothing right now. It's not running, it's not testing anything. But as soon as we cause an event, and we do that by for instance, turning a switch on, then the code inside is run, and it does whatever it's told. In this case, turning on port A. Now, the same is true for when you turn the switch off. That's also an event. When the switch turns off, it will run the code again, and in this case, it's matching pin D to port A. Okay, well, thank you so much for bearing with me as we talked about the inputs and outputs. Now we can actually start to utilize the abilities of the Lua controller and combining some of our previous knowledge of the if statement. So next class we are going to dive into controlling things with, and we're going to incorporate the if statement into that code that we've been writing in the Lua controller. So thanks for watching, guys. I will catch you next time.